All right, so let's talk about combining like terms, or as we call it a lot in Miss Smith's class, Skittles and M&Ms. Skittles, great on their own. M&Ms, fantastic on their own. But you mix Skittles and M&Ms together, they are disgusting together. So we want to make sure that we are keeping all of the like terms together and we're not combining stuff that doesn't belong. So let's talk about what this means without candy and in the math world. So we have two types of tiles that we will use. Our tiny tiles are called unit tiles. So we have positive and negative unit tiles. So these will always be look like squares or circles. It kind of just depends on what the person decides to draw. But these longer rectangle tiles are what we call X tiles. Remember, X is just a variable. It's representing an unknown number. But just like you can have a positive and a negative unit tile, you can also have a positive and a negative X tile. And here's the good news. Simplifying with X tiles works the exact same way as simplifying with our unit tiles. Think back to our integer unit where we talked about our rules about how when we add, if I have one positive and one negative and I put those together, I get 0. We call those 0 pairs. So I can take one positive unit tile, one negative unit tile, and I can add those together to get a 0 pair, a value of 0. I can do the same thing with X tiles. I can take one positive X tile, one positive negative tile, or excuse me, that didn't make sense. One positive X tile, one negative tile, and when I combine them together, a positive X plus a negative X will still just give me a value of 0. But I can only make 0 pairs with like terms, which means I can only make a 0 pair out of a positive unit and a negative unit, or a positive X and a negative X. I can't make a 0 pair with a positive X and a negative unit. That's like mixing the Skittles and M&Ms together. We don't want to do that. Now, we keep saying the word term. Term. So let's talk about what a term is. A term can be 3 different things. A term could be a single number, like the number 12, or the number -10. Okay, one single number. Those are both considered terms. A term could also be a variable like x or -y. Okay, both are just a single variable. Or it can be a combination of numbers and variables together, like 4x or -5y. Okay, all of these are examples of terms. But you're going to know that you have a separate terms based on if there is an addition sign or a subtraction sign between them. So, for example, if I gave the expression 4x plus 7 minus 2y, if I wanted to count the number of terms that I have, I need to look at what is on either side of my addition or subtraction signs. So I have 4x is one term, 7 is a second term, 2y is my third term. So this expression has a total of 3 terms. Now, we talk about terms a lot because we're going to work on, like, again, combining those like terms, getting all of our X tiles together, all of our unit tiles together. So when we look at these two pictures right here, the picture on the left, I see nothing but small tiles, which we call unit tiles. And I see that I have some negatives and some positives in here, but they're all unit tiles. Over on the right side, I see that I have some positive X tiles and some negative X tiles. Again, that's okay that some of them are positive and some of them are negative, but the important thing here is they are all X tiles. It's like having all of my M&Ms together on one side and all of my Skittles together on another side. So when we group this, when they're separated from each other, this is what we call having like terms. All of my units are alike each other and they're together. all of my X tiles are together and they are like each other. So we can take tiles of the same shapes and size and they can be combined. What we've done here is okay. But when I look over here, I've got 4 different pictures here. And this picture has a positive X and a negative unit tile. This picture has a positive X and a positive tile. This one has a negative X and a positive tile, a negative X and a negative tile. These are all different from each other. This is like having a Skittle and an M&M in the same bag. This is what we call having unlike terms. I've grouped things together that don't belong. So when I have tiles of different sizes and different shapes, they can't be combined. I can't do anything with that. So here's what I mean when I say that I can combine them or I can't combine them. Let's go back over to my like term side. I'm going to start right here where I have just my unit tiles. So if I were to count, I have 1, 2, 3, 4, 5, 6, 7 negative unit tiles for a value of negative 7. If I count my positive tiles, I have 1, 2, 3, 4, 5, 6, 7. I also have 7 positive tiles. Now again, I can make 0 pairs if I have like terms. So since these are both unit tiles, I know that 7 positives and 7 negatives would give me a value of 0. Let's look at my X tiles. I see that I have 3 positive X's for a value of 3X. I see that I have 1, 2, 3, 4, 5 negative tiles for a value of negative 5X. Again, they both have X's attached to them. They're both the same type of term. So I can simplify this expression. So if I have 3 X tiles, 5 negative X tiles, let's make some 0 pairs. I can get rid of 1 positive, 1 negative, 1 positive, 1 negative, 1 positive, 1 negative. And that would leave me with the value of negative 2X. I have 2 negative X tiles here. But when I look over here at these few pictures, I don't see stuff grouped together in liked terms. In the top left, I see that I have a positive X tile and 1 negative unit tile. Well, this is like Skittles and M&Ms. I can't mix the two together. Just like here, I have a positive X and a positive unit tile. Again, I can't combine these together. It wouldn't make sense to add an X and a 1 together. Down here, I have a negative X and a positive unit tile. Again, they're different things here. A negative X and a negative unit tile. Again, all different things. I can't add or subtract those terms because they're unlike terms. So let's put this to action here. Our first problem says, which expression is equivalent to 2x minus 3x plus 3 plus x? So here's my strategy when I solve. I go through and I circle all of my x terms and then the sign that is in front of them. So the addition or the subtraction sign. So I'm going to circle 2x. Since there's nothing in front of it, I know that that is a positive 2x. I'm going to circle the minus 3x, which when I separate it looks like a negative 3x. I'm not going to circle the plus 3 because it does not have an x tile to it, next to it. But then I'm also going to circle the plus x, which again, when it's separate, looks like a positive x. So then I'm going to pull my x tiles over here to the side. So I have 2x minus 3x plus x. And all of these things I can simplify. So I'm going to start, because my order of operations says when everything is additive, I start on the left and I work my way to the right. So 2x minus 3x. Since I'm subtracting a bigger number, I'm going to use LCO, which becomes 2x plus negative 3x. They're different signs, so I subtract and keep the sign with the most. So my sign with the most is negative. 3 minus 2 is just 1, so this simplifies to be negative x plus x. Well, 1 negative and 1 positive just gives me a value of 0. So I actually get rid of every single one of my x tiles. And then the only thing I'm left with is plus 3. So this whole entire expression just has a value of 3. So we need to go through our answer choices and figure out which one also has a value of 3. So answer choice A, I'm going to circle my X tile. And when I look at it, there's only one X tile, and I have 6 of them. There's nothing to combine it with, which means at the end of the day, I'm going to be left with 6 X tiles, and I'm looking for something that has 0 X tiles. So A cannot be my answer. B, I'm going to circle my negative 2X. I'm going to circle the plus 3X. I'm going to come over here to the side to make it negative 2X plus 3X. And when I simplify this, my signs are different, so I'm going to subtract and keep the sign with the most. My sign with the most is positive, and 3 minus 2 gives me 1, so this simplifies to be X. But again, I don't want any X's, so B can't be my answer. C, I'm going to circle my negative X. That's all I have, so that's all I'm going to be left with. C cannot be my answer. And then let's simplify D. D, we're going to start with 5 plus negative 12, different signs, so I need to subtract and keep the sign with the most. So the sign with the most is negative. 12 minus 5 is 7, plus 10. Again, different signs, so subtract and keep the sign with the most. 10 minus 7 would give me 3, and positive is the bigger sign, so I get a value of 3. D is my answer. Our next one says, which expression is equivalent to 12x minus 13? This one's already simplified for us. I have all of my x tiles together, all of my unit tiles together over here. So we just need to go through and simplify our answer choices. But I see one right off the bat that I can automatically get rid of because it doesn't contain any x tiles. And that would be answer choice D. So I'm going to get rid of answer choice D. There aren't any x tiles. Since I'm down here, I'm just going to work my way from the bottom to the top. So I have C. So I'm going to circle the 8x. I'm going to circle the plus 4. So if I have 8x plus 4x, that would give me a total of 12x plus 13. But our problem says minus 13. So C is incorrect. I'm going to move over to B. I'm going to circle my plus 2x. My plus 10x. So 2x plus 10x would give me 12x. Then I have negative 5 plus negative 8. Those are same signs, so all I need to do is add and keep the sign. So it would be negative 5 plus negative 8 gives me negative 13. Now on this one, it looks a little bit different than what I have, but we know, thanks to LCO, that 12x minus 13 is the same thing as 12x plus negative 13. So B is going to be our answer, but for the sake of our notes, let's prove answer choice A as well. Answer choice A has exactly 12 x's, which is exactly what we need. But when I solve 20 minus 7, that would give me 12x plus 13. So again, doesn't match what we need. So I get B for my final answer.